All right, folks, we're going to do some graphing. We're going to graph some systems of inequalities. Now, I made a big deal in the last lesson that we don't solve systems by graphing them. That's just to understand what the solution to a system is. It's where they cross. Now, with inequalities, we kind of, if we're going to have any semblance of what the answer is at this point, we have to graph them. And so let's jump in and remind us how to do this. This is still probably review at this point, but we'll see where we go. So we've got a little system of inequalities sitting right here, ready to go, and we're going to graph it. Now, we learned in our last chapter, our last unit, about we remembered about graphing inequalities. And so it's the same thing for that part. It's just the only tweak is how we're going to shade it. So what we're going to do first is we're going to get both of these lines on here. One of them is going to be dotted and the other one's going to be solid. Remember, that's what that we tell that with this guy right here. So let's start by graphing this one. So we're going to go up to the y-intercepts. We're going to count up 1, 2, 3, 4. We're going to put a dot. And then we're going to count the slope. So the slope here is 2 over 1. So we're going to count up 2 over 1. We're going to put some dots on there, all of those things. There's all our dots. There's a line there looking beautiful. So then I'm going to connect the dots. But like I said a second ago, this one is not equal to. So what we want to do is we want this to actually be a dashed line or dotted line, right? So we're going to make sure that that is correct. So that's the not equal to bit. Now, I'm not going to shade yet because I'm going to wait and get the other one on there, and then we're going to figure out where we're going to shade. So for this other one, may as well go ahead and use a different color here. This other one, we're going to find the y-intercept. Oh, shoot a monkey in the face with a bazooka. Let's did y'all catch my mistake? I totally made a mistake, but luckily for me, I am on a computer and can just go down to -4 and cheat there. There we go. Let's put this where it belongs. Let's make that, because that's a negative. That's a negative. I make mistakes too. We all make them. -4. So we're gonna put dots there and there and there and connect these dots and make it dashed. There we go. It's a little uglier, but that'll be the monument. That'll be the testament to my errors. All right, let's go to this one. So we're going to go to the y-intercept of +3. 1, 2, 3. Sorry, the air is getting dry, I think, and all the things. My throat doesn't like talking. So I've also been teaching all day before this. So anyway, here we go. So y-intercept of 3. Now we got a -1/2. So we're going to go down 1 over 2. Down 1 over 2. We're going to get our dots on there. You don't have to put this many dots. It's just easier for me because of the way that I form these lines using the computer. Now this one is going to be a solid line, right? This one is solid because of the equals to. So now we got to figure out where we're going to shade. And where we're going to shade is just like a solution to a system of equations is the intersection of those lines, right? So the solution to a system of inequalities is the intersection of where these are both true. So let's take a look at this one. So for the pink one here, it's greater than. So we would be shading above. So that would be this direction, right? Above the line. And this one is less than or equal to. So we would be shading below the line. So what we're going to do is we're going to shade the kind of the pie piece where those are in common. So we're going to shade not up here and not down there, but we're going to shade this pie piece right here. Grab something a little different. And so we would shade this section here, right? So all of this is what we would shade. Everything in that pie piece, everything that's in common, all of those bits. May as well add some pink in there, make it all kind of match and go together. Isn't it cute? I don't know. I could sit here and play with this for an hour and a half. I don't know. That maybe not just this thing by itself, but there you go. So it's shaded and it's where it's in common between these two things. So let's do another example. Okay. We're actually only gonna do one more example, and then we're gonna be done. So here's the next one. Next one looks like that. So let's graph this thing. Now you might notice something about this already. I hope you do. I hope we're starting to see some patterns and things quickly, right? So let's take a look at this. I'm talking about the slope, by the way, in case you're still lost in the woods. So let's graph this guy. So we're going to go up 1, 2, 3, 4, 5, and then up 1 over 1, and then right there. Whoop. That's close to where it's supposed to be. Pretend like it's down a smidge. It's not going to make any difference for the final product here. So that's this guy, and then this one is going to be below that. I'm going to keep them both green just because we can. So I'm going to go down negative 1, 2, 3, 4, up 1 over 1. So that's right here and right here. There we go. So those lines are parallel. So if this was just a regular system of equations, you would just write no solution and move on with your life, right? So there are two options at this point if the lines are parallel. We might have a solution and we might not have a solution. So actually there are three options. So if the lines are parallel, here's the options. Either they're both shaded up or down, and then we would shade everything, and one of the lines doesn't matter. It's just going to be like shaded, right? So if they're both shaded greater than, then it'd be something like that. If they're both shaded less than, then it would be something like that, where it's just shaded for one line down and the other one doesn't even really matter. Okay, so the other option is if the top one is less than and the bottom one is greater than, then we would shade in between them and it would have a solution, right? It would have, because it has a common intersection of shading. So let's take a look at this one. This one is greater than on this top one. So it's above. Okay, so we might be like that. Except we're not, because this one is less than. So we would have to shade outside. So we can't, there's nothing in common. So this one here really does have no solution. Or you could call it the null set. Both would be applicable depending on your level and all of those other things. So there you go. That's it for this lesson. This one is also probably, hopefully, pretty easy. I hope if you can graph a line, you can do this one. Our next lesson, we're going to talk about 3x3 systems. That one's definitely going to be more involved. We will see you then. Bye-bye.